Hey, what's going on? Welcome to another episode of AngularAir. I'm your host, Justin Schwarzenberger, and on today's episode, we are going to be talking Angular tooling. We have an amazing guest that knows a little bit, well, a lot about the subject, so it should be a really good discussion. So let's get after it right away. Introduce our panelist here. Today, we've got Austin McDaniel with us. Austin, how's it going?
How's it going, everyone?
And we got Bonnie Brennan with us. Bonnie, how's it going?
It's going great. I'm excited to have Minko here. I love Minko.
Yeah, and our guest today is Minko Gechev. Minko, how's it going?
Hi, it's great. Thank you for having me.
Yeah, thanks so much for coming on. We're really excited to have this discussion. I am. I'm sure everybody else is. So, Minko, why don't you tell our viewers a little bit about yourself? Give us a little background for those that don't know.
Yeah, sure. So currently I'm working on a startup, Rhyme.com. We're about to release our initial public beta maybe in a couple of weeks. So I'm really excited about that. Really excited about it. We've been working on it for quite some time now. And in my spare time, I'm doing a lot of open source. So I've been working mostly on Angular tooling recently. So that's why this topic is specifically exciting for me. So I've been working on different tools for static analysis of Angular application, visualization of source codes, and contributing to the Angular score and others.
Nice. Yeah, we know, familiar with your Codalyzer work, right?
Yeah.
Then you have several other tools that you have out there for analysis and all kinds of different stuff, including one. Didn't you recently have something with Minecraft and some tooling?
Oh, yeah. I built a Christmas edition. So, yeah, basically you can compile your application to virtual reality and walk around your code. Yeah, that was fun. And for Christmas, I made it with Christmas trees. So you basically are in a Christmas tree garden where you can walk around and see your Christmas trees, like the snow it's snowing. You can see different Christmas, like different toys on the Christmas trees, depending on the directives of your component. It was completely useless and a lot of fun to build.
That's so cool. What do you just have this innate passion for this type of stuff in terms of the topic? Yeah.
Yeah, I'm actually passionate about compilers. I really prefer to build useful things, but yeah, this one was kind of an exception. It was for, it was.
I think you're the only person I know that's actually said they're passionate about compilers.
I know a few more guys. Yeah, we actually started. So we are trying to establish a reading list where we're reading about compilers, like papers about compilers. It's really hard to find other members of this reading club. So we're only 2 people for now. So I can understand that what Austin is saying.
Yeah, that's one of the things I find really fascinating about Minko is his passion for the compilers, which, like Austin said, is kind of going. Well, I can't even imagine like being excited about that. But then because of that, all the things you develop and it's amazing, so it's exciting.
Thank you.
I was really intimidated the first time I met Minko. But I was asking him questions and he just knew everything that I wanted to know, right off the top. And I thought these were super advanced questions. And every question I asked him, he was like, oh yeah. And he'd talk about that, nothing. And then once I got to know him, he's the nicest guy in the world. So it's hard to be intimidated, but he's still pretty intimidating.
Oh, thank you.
Okay, since we're gushing about Minko, I'm going to say one more thing here too that you do. You do a lot of talks and presentations, and I'm always amazed by the quality of your talks. And you had one recently at Angular Connect where you talked about performance, and it was phenomenal the way that you walked through that and taught people the different steps and unfolded that. So I just wanted to plug that as well too. Excellent speaker.
Thank you very much. Thank you. I'm trying to. I still have a lot of work. I have some bullet points that I'll be working on this year. Hopefully, the quality will improve further.
And you are going to be at ngConf.
Yes, I'm doing a workshop there about performance.
There you go. We're going to have so much fun.
Yeah, looking forward to it.
Totally looking forward to it. All right, so tooling. Tell us about tooling. Let's talk about the Angular tooling and yeah.
Yeah, well, so I'm very excited about what's happening in the Angular world regarding tooling. This is because of several reasons. There is great tooling in general for scaffolding and for bootstrapping applications, like in each individual framework. Like we have Create React App for React, we had Yeoman before, we have the Vue CLI and React CLI and everything. Of course, in Angular, we have the awesome Angular CLI as well. Unfortunately, Mike is not here today to tell us more about that. And schematics. But on top of that, Angular is super convenient for tools for specifically for static code analysis. And the compilation topic, like the entire topic about compilers in Angular, is very essential as well. So this is because of several reasons, but mostly because of the very good foundation, very good design of the framework itself. So it is not only built with TypeScript, which allows us to collect a lot of metadata for our application because of the type information, but also the templates are built. They were built with tooling in mind. That was part of the design docs when the framework was initially developed. So the templates they have very deterministic meanings, like each individual syntax there. Basically, you can statically analyze them and make some conclusions for your Angular's application's properties based on them. So I think this is a very powerful aspect of the framework.
Yeah, that whole TypeScript story, I think, is really paying off, right? Of the adoption and acceptance of TypeScript into that, because not only for all the strong typing and things like that, but it seems to be allowing us to accomplish a lot more of these things around this analysis and things like that seem to be extremely powerful, right?
Yeah. Yeah, there are some small things, and in the templates there are some small things which are just making Angular so much easier for analysis compared to AngularJS, for instance. In AngularJS, we were able to pass, well, we had a variety of ways to pass a value to, well, it wasn't an input back then, it was called something else, but we were able to pass a value using interpolation by internally invoking the expression evaluator, however that was called, in order to evaluate the expression that had been passed to the directive in specific context. And we had another way as well. So we had 3 different ways to pass a value to a component, compared to now where we have only the single way, where we pass either a constant or we pass an expression which is being evaluated by the framework. So this deterministic nature of the framework is extremely helpful for us.
So is this stuff that benefits? I mean, where do we see the benefit of this? Is it like in our editors and IDEs, we get additional functionality from there? Is it the compilation of Angular itself and the Angular compiler and things, or what other places do we benefit from all this being there?
Yeah, that's a perfect question. So there are several things. Of course, we have great editor support. Thanks to the great design of the framework, we have tools like the Angular's language service, which basically it collects the metadata for our entire application in order to be able to track the individual template references and to provide auto completion in the given context. So we have the language service itself. It provides great development experience, and it is only in its early days, so it's going to improve a lot in future. And on top of that, thanks to the compiler and to the good design of the framework, we can see something like Ivy, which is showing up in the framework and decreasing our bundle size with 90% or so. So because of the statically analyzable nature, let's go this way, of the framework, we are able to perform a lot of compile time optimizations. So basically, the way that GCC optimizes C on very low level, we will be able to do something like that with Angular, and we can have extremely powerful results.
So where do you see, I'm going to get off on a side note.
Yeah.
Where do you see WebAssembly playing in with this?
Yeah, well, so that's first, we are not limited right now. Right now, we are not limited to compilation targets, the compilation targets of our Angular applications to be JavaScript. We can compile them to anything. We can even build something like Ember to build a compiler to our own intermediate language and build a virtual machine which evaluates everything. Like, we can do crazy stuff. With WebAssembly, I'm not sure how the Angular team is going to approach the problem. Well, currently, basically WebAssembly is some stack-based virtual machine which is very, very performant, and this is one of the well, it's about 2.5 times faster compared to JavaScript right now, right? That's what I watched on Google I/O last year. So eventually, it can improve the performance of our application if we compile the change detection of the ngAir app to WebAssembly instead of JavaScript. Eventually, to some extent, I guess this is one potential approach. But there is also the step that well, WebAssembly doesn't have access to the DOM, so there is also this payoff where you need to communicate, where you need to implement some kind of message passing in order to communicate between WebAssembly and JavaScript in order to synchronize the changes into the DOM. So it's very challenging and interesting thing to see. Yeah, basically, I'm looking forward to see a design talk about this from the Angular team.
Do you think that the way that Angular and the platform is scaffolded and built out, like, allows it to be able to adapt to these sort of things easier than, say, another framework?
Yeah. Yeah, I'm pretty sure. Well, yeah, Ember are doing pretty good job as well. So I'm confident that they can very easily take advantage of WebAssembly as well. It's, if you're interested in compilers, I guess Ember and Angular. Ember is even in more pure form because they built entire, like, you can see something like WebAssembly as output of their compilation process. But it's their own, like, intermediate language. So yeah, I think Angular and Ember can take advantage of these of WebAssembly pretty easily.
I wonder how many Angular developers actually think about or realize or are aware of the whole compilation part of the whole equation, right? That Angular has this Angular compiler, right? That it's not just TypeScript transpiling stuff, but it's all this extra stuff. I mean, maybe we don't need to know about it too much, or maybe there's awareness of it. I don't know. I'm curious.
Yeah, I think there is one very important thing that we need to realize. So we don't have to know how the compiler works, like, in details, although it's always fun to know that. Like, but it's definitely interesting to realize that Angular's version of TypeScript is slightly different compared to the conventional TypeScript that we're used to. And this creates some kind of inconsistency sometimes between developments, creating an application, like building an application for development with the watch mode of the Angular CLI, and after that, building it for production. Because Angular supports some large subset of TypeScript. So, for instance, it cannot infer sometimes what the context of a given provider factory is or whatever. So this is a very important thing to keep in mind.
One thing on that, like, for the viewers, like, we're talking about TSC versus NGC, right?
Yeah, that's a good point.
Right. So, like, if you run TSC, like, it's not exactly the same thing as when you run, like, ngBuild, which the CLI provides, which is actually running the Angular compiler underneath the hood. And correct me if I'm wrong, because I'm not the compiler expert on the call.
Yeah, you're correct. Yeah, you're correct. So internally, the development mode is compiling. So what the compiler does in general, it takes our Angular application, the way it is, that we see it, and it transforms it to some more efficient version of itself. So it is going to transform the templates to some JavaScript calls, which are...
Right?
Well, that's in both cases. With JIT, this is going to just happen in the browser. That's what the compiler is going to do. Just take our application and transform it to some more efficient version. So the templates are not going to, just going to be translated to JavaScript calls, which are going to render like everything very efficiently. So of course, the compilation, it can happen either ahead of time. You can just this can happen before the user opens the application in the browser, or it can happen just in time. So the user opens the application in the browser, and like this compilation process happens. The templates are being translated to JavaScript, and after that, they're being evaluated and rendered. The interesting thing is that usually when we're doing something runtime, we have more metadata. So this is a little bit like we're getting into too much details, but the interesting thing is that we just have more information when we're compiling our application in the browser because of runtime information. So what happens is that with the more metadata that we have for in just-in-time compilation, sometimes the user can use some constructs which cannot be inferred statically as part of the build process, but they can be inferred in the browser because we have this runtime information. So this creates the inconsistency between ahead of time and just-in-time compilation, which means that sometimes the development, when running Angular CLI in dev mode, some of our applications can work, but they may not be able to compile ahead of time. So this is going to be solved.
And just to be clear for everyone, those are the errors that you get in production that you don't get locally, that are like vague, like function cannot be like invoked with a decorator or something like that. I forgot what the exact one is.
Yeah, correct. Yeah, and this can be solved very easily if we use ngC, the Angular compiler, for both development and production mode. And for development mode, we just need to take advantage of the. I think it is you already can run Angular CLI with ahead of time compilation in dev mode, right? With a flag.
Yeah, it's not enabled by default, I don't believe, just because it does slow down the build process. But I think they are working on, and Mike could probably answer this better, but they're working on improving that so that like it doesn't have any impact.
Is there a reason why we would not want to be just doing AOT all the time? Or, you know, is it something that as we approach building going forward, it's just like we should just be building for AOT and focused on that?
Yeah, there is no reason to not use AOT. It's better for all cases.
But it's slower.
Yeah.
To build.
Yeah, that's one more compilation step on top. So in the best possible scenario, it will be just a little bit slower compared to TSC.
But I think one of the things you mentioned was that additional data right there on the client side for when you're JIT mode, right? Maybe the possibility of doing some more dynamic stuff if you needed to do that, right, and accomplish that, and that was a value added to your app. Maybe there's a reason why to still run JIT mode. I don't know.
Yeah, that's a good point as well. Well, also sometimes the produced output out of the ahead of time compiler is slightly bigger compared to our actual application. I don't know how this is going to go with Ivy. Maybe Ivy is going to make the magic.
And people probably, if they're not in like the super loop, don't know what Ivy is. Can you kind of tell them a little bit of background there?
Oh yes, actually, I just saw that Narwhal released a course about this where they're mentioning Ivy. So Justin might be even a better person to tell us more about it.
Yeah, so from what I've learned and what I've heard and talking is that ngIvy is really it's the code name for the new version of the renderer that's going to be much more efficient and create the smaller footprint for your code for your templates that it compiles down to the set of instructions that need to run in the browser, right? So it's going to be more efficient at that. It's going to be a smaller set of instructions. So supposedly we're going to get a lot smaller payload that we can do, as well as speed and stuff. Yeah, awesome. Also, a nice little comment that says, or is it's just renderer? I think it's just document, because actually I think distilling it down to really just getting to the document object and working with that. But yeah, we're supposed to get better speed, better errors and debugging that we can see in order to trace down those things, like kind of what Austin, what you mentioned earlier about this obscure error. We should be able to trace that down better. And I think all around superness. I mean, that's what I hear. I'm looking forward to that, hopefully. So,
do you guys know where the name Ivy came from?
I have heard yes and no on it. So if you want to say something about it, I don't know though.
I heard, and I actually got a big kick out of this because it's so genius and it's so simple. But it's an injected view, right? So it's the letters IV, and when you say them out loud, it sounds like Ivy, which kind of sounds like a cartoon villain. But I thought that was super clever. So yeah, so IV stands for injected view, but we call it IV, which I thought was cute.
Cool. Yeah, well, whatever it is, we can't wait to get it, right? Should be a lot of good performance. So we'll see. So you
can get it now. You can get it now. Beta 6, I believe, is what it's at. Download it from npm.
You can turn on the Angular compiler option flag to enable it. I'm not sure that you're going to get much functionality out of it. They're still, filling in all the support for it. I think the idea is that it's going to, replace have all the same functionality as the existing render. So when it goes live, we as end users, we don't have to do anything to our code to change anything. We will just get it, right? But it has to have that parity with the existing render before that's.
Yeah, but you do get major street cred from being an early adopter.
I think not sure what we can. Yeah, but.
Bonnie, are you going to go and update your application to it?
I think so. I am. It has a cool name, so I'm just going to use it just for that. Yeah.
Okay.
But
so,
yeah.
Go ahead.
Well, we had lag earlier because I thought you were done talking and I started talking, and then all your talking came through. But I was just saying, I think early adopters get major street cred. So if you go in there and start using it and give some feedback, then that's worth points.
All right, so Bonnie's dishing out street cred to anybody who enables it.
There you go.
I'm going to give out street cred stickers that say like #street cred at ngConf.
When my daughter was in junior high, every time I said something she liked, she'd be like, "Oh, you just got 100 cool points." And I'm like, "I'm getting cool points from you? You're a teenager. You can't do that."
That's how it works. The younger generation cool points. It's always how it works, right?
Yeah, yeah.
Okay, so we talk about how this whole stuff helps, our tooling in terms of our IDs and editors, and how it helps the compilation of Angular itself and the power that comes along with it. What about things that allow us to do like debugging or analysis and things like that? I think maybe talk about augury and what that does and how that provides something like that, so we can kind of look at our running app and figure stuff out.
Yeah, augury, Rango, they built this Chrome extension augury, which allows us to see our application structure clearly in our DevTools, see some, basically, so I have structured, so first we talked about compilation, the ahead of time compiler and the compiler in general in Angular, and how just the just-in-time compilation has some more metadata because of the runtime. So augury is entirely runtime, and it can get. So in order to use augury, we need to run our application in Chrome. We cannot use it without that. Some other tools out there, they can analyze our application or visualize our application even without running it. So there's a difference between static and dynamic analysis. And with augury, we can have great development experience there. We can see the dependencies between the individual providers, for instance. We can see the state of given component at given points at time. So we can it's very convenient for runtime debugging.
Do you ever see these things like types and things like that, right? They're stripped out at build time. Do you ever see like a play for them moving into like some sort of metadata and runtime type checking?
Runtime type checking. Initially Angular started with this add script, right? It was performing entirely, like everything was happening there runtime. So it had runtime type checking with some type assertions. The runtime type checking could be useful as well. So for instance, if we write our types strictly enough, we may eventually not need it. So this is going to strip some runtime overhead, because these assertions, there are still some operations which are being performed. But still, some issues eventually, I guess, can be caught by runtime type checking as well.
I mean, obviously, some people think runtime checking is important, right? Like we have React that has the props, right? That you can define, you know, string and all those different things. And, you know, in pretty much every other language, C#, Java, we have runtime checking.
So we have, yeah, Java is strongly typed. So if we try to do something between, and Python even is strongly typed with runtime type checking, I prefer to still catch my bugs ahead of time with compile time type checking. Otherwise, I have to have also low. So there is also this boundary between very high test coverage. If you have 100% test coverage, probably runtime type checking is perfect for you, but you still need to run your tests. With compile time checking, you get something like this 100% test coverage ahead of time. So I'm not saying that you should not write tests if you use type checker. Of course, it cannot prevent you from having logical errors in your code. But you don't have to have 100% test coverage in order to make sure that you don't have incompatible types in your system.
What do you feel about you know, like really fully embracing the type thing, right, in terms of writing, and is that something that should be encouraged for people to be doing because of the fact that now you can get this build time checks and identify these things ahead of that to hopefully save you that time, you know, because obviously there's an expense, you know, a lot of people maybe not think about in terms of discovering an issue at runtime, right? And not only the fact that our users of our applications now experience that, right? But also the fact that it becomes harder for us to maybe replicate that, to set up that scenario to try and identify what the actual bug is and track that down. And if we can discover those things ahead of runtime, you know, at the compile time, it's going to save us some of that overhead. I mean, is that something that we should be strongly considering here?
Oh, yes, I'm definitely encouraging type systems. I'm definitely a fan of static typing. So I know there are people with different opinions on the topic, and sometimes the compiler may feel a bit more strict than we want to because of strict no checks, for instance. We might be sure that given properties never no, but we still need to perform the check in order to satisfy the compiler. I think it's a good idea to have such tooling, and if we are not happy with it, instead of denying it, we can just try to improve it.
My favorite type is any.
Yeah.
Yeah, I wonder too, maybe selling it, you know, in terms of saying like, look, this is important. And not only for all the stuff we kind of mentioned, but also I think the more of that we have turned on, the more that we have, then the Angular compiler can do more things potentially with it, right? Is that a fair assessment that we could actually now, leverage the stronger types throughout to maybe do even more performance stuff and more things like that?
Yeah, that's a good point as well. So that's another low-level thing in the JavaScript virtual machine. But if our source code is... So for the JavaScript virtual machine, it is not obvious what the shapes of our objects are and how given property needs to be accessed. So the virtual machine doesn't know if our object has property full and bar or only property bar. And it doesn't know in memory like what the displacement in memory of the property bar is going to be of given object, because it may have other properties as well. So this is related. So what the JavaScript virtual machine tries to do is to find out where the property bar is located in memory and try to access it the first time. So when it finds where exactly it is, it creates the so-called inline cache. So the next time it doesn't have to go through the entire property resolution algorithm, and it can just directly get it from memory. This is information which so if we have static types in our application, we are going to be sure that the individual objects are always of the same type, and the JavaScript virtual machine inline caching will always work. It's not going to require the optimization of the source code. So yeah, as you said, types can eventually boost the performance of our app as well.
I gotta say, you know, the more you describe this stuff, the more tips you share, it kind of gets me a little excited about compilers. I got to be honest. I mean, this is fascinating. You know?
Yeah, it's really fun. I actually on Angular on NG Cruise there was this hack night, and we were going to write some code with the other attendees. So yeah, everyone says, "Well, do you want to read some brainwaves with me or do some IoT stuff?" And like everyone was super excited. After that, it was my turn. So I said, "Anyone wants to write a compiler with me?" It was complete silence. Yeah, so I ended up writing a Pong game or something like that. It was still fun. We did some reactive stuff.
Now, don't you have a post that you wrote like a small compiler in JavaScript as well?
Yeah, so first I wrote one compiler. So first I wrote one. Well, it's just a tiny functional programming language with type system. It's not a general purpose programming language, but it was definitely fun. So I went through even the math, which was the exciting thing for me because yeah, I'm just curious in doing research in this direction. And like maybe I had 2 visits or something like that. So after that, I decided to, well, there are more for sure, but after that, I decided to create a compiler, small compiler, just very limited subset of what I built initially, without type system, without anything. So yeah, in the end, it came up to 25 lines of JavaScript for both a compiler and interpreter. And it got much more popular. And after that, the blog post about type systems got more attention as well. So I think that's the way to go. You just try to create a very small, tiny model of a complicated concept in order to let people see value in it and appreciate it. That's how I learn in general. So I mean, if there is something which sounds scary, I just ignore it.
I feel like having some sort of knowledge about this topic, right, about the compilers, maybe not too deep, but having an understanding, especially with understanding what Angular is doing as well, potentially helps us write and think about our architecture of our Angular apps. It may be more efficient, maybe better. You know, would everybody agree on that? Is that something that, you know,
Especially
it's worthwhile to
debugging.
say, look, at least dive in and kind of get this higher level view of it, because it's going to help you be thinking about those things when you go to write your actual code.
I think especially for debugging, like we were talking about with like AOT issues and things like that, you know, having an understanding of kind of what's going on under the hood, I think can really help you debug some of these issues. Like, why is this like throwing this error, right? Like if you kind of have an idea of what's going on, you can, you know, diagnose that and fix that a lot easier instead of just like Googling until like you find something.
Cool. So, okay. So next stuff, I see we have a little bit of outline, some more stuff to cover. Can we talk about the static analysis of Angular apps and maybe some of the other things, the benefits that it can bring? Like, how about refactoring code or anything like that? Is that something that gives the benefit?
So this is again the static and dynamic analysis that we discussed, JIT versus AOT kind of thing. Not necessary, because with the analysis we don't need to emit code, we just analyze code, the intermediate representation. So compared to Augury, tools like tslint, let's say, they're consuming our source code and they don't know how it can be executed. They just, well, they can infer, I guess, but they are just using what is out there in our source code. And with tslint, what happens internally is that we're taking our source code, we're building some intermediate representation of it, which is just a tree. And trees are convenient for traversal and for analysis. So we can just traverse this tree, which is representing our source code, and make some decisions out of it. So that's it. That's what the static analysis usually is. tslint is very useful for catching some linting issues, of course. Linting issues could be considered, they can be related to functionality, to style, and others. And with tslint, the cool thing is that once we have concluded that there is something wrong inside of our source code, after traversing this tree, what we can do is just to transform this tree a little bit, adjust it in order to fit the correct style, and right after that serialize it to JavaScript again or to TypeScript. So that's these are actually the auto fixes, the refactorings that are happening all the time.
You could put the prettier tool in that same category.
Yeah, there is that's what I was thinking the other day. There is very thin boundary sometimes between linting errors, between compile time errors, linting errors, and style errors. So usually I prefer to use formatter, because otherwise, well, why would I use tslint to tell me that I haven't put the opening brackets on the line where my if condition is, if prettier can do that automatically for you, and I don't have to fix it manually. Of course, with tslint autofixes, they can fix it as well. But yeah, the formatter usually catches only styling errors, and the linter should focus on linting errors, which are not compile time errors. Sometimes it's not obvious where the boundary is.
I think there's you wrote Codalizer, which is kind of a linter, which catches style errors. So
it catches actually both. It catches linting errors and style
I was playing
errors.
devil's advocate.
So yeah, with Codalizer, Codalizer extends tslint. So with tslint, what we can do is just analyze TypeScript. But in Angular, we have a few other types of languages inside. We have CSS, which we can embed inside of our component. We have the templates, which is actually another programming language in the end. It's Turing complete. You have ngIf, ngFor. You can do everything there.
And just so people know, right, like if you don't know what Codalizer is, if you're using the CLI and you see errors like you didn't implement on a init interface, that is Codalizer under the hood showing you those errors, and he wrote that. So
this is and it also analyzes, my point is that it also analyzes templates, styles, and Angular has also tiny language inside of the values of some attributes. So for instance, if you have ngIf, you can inline a tiny expression there, which is not JavaScript. It's just a DSL. It's just a template language that Angular has. So yeah, Codalizer extends tslint in order to provide analysis for templates, styles, and such expressions.
Now you mentioned style. Like, do you mean CSS style or?
Styles. Yeah, CSS. Also,
does Codalizer have plugins for style CSS?
Yeah, it supports Sass and everything out of the box. You just need to provide it provides some hooks. So it is going to pass your styles to the function which implements the actual transformation of code. So what is going to happen is that Codalizer finds that your component has some styles. It finds out that your styles are Sass. It passes them to your hook, which compiles your Sass to CSS. Codalizer analyzes the CSS, and right after that, based on the source map, outputs the errors in your Sass files.
I don't think I've ever seen it give me errors in Sass files. Is this like, you have? Yeah?
I have, yeah.
You have to be really talented to create those errors.
Or the exact opposite, right?
I know I'm using style right now for those type of things.
Yeah, well, there are no any rules right now which are for styles. So, but if we want to, we can implement them.
So, like with Codalizer, right? It has this ability to analyze the template, give us input about the templates, right? You're talking about the template syntax and things like that. If we didn't have Codalizer there, but we ran the GC notifications about those things, is it kind of doing that same stuff in some levels? Does that make sense?
Yeah, that's a great point. So we have the compile time errors, which are being thrown by ngC, and we have some let's say linting errors. So Collizer is focused on the Angular style guide, which shows us how to write idiomatic Angular in the end. So a few years ago, I worked with Igor Minar, with John Papa, and with Ward Bell on the Angular style guide. It was really exciting to have a chance to work with them on such fun thing. So we came up with a style guide, and I decided that it might be a good idea to analyze an Angular application statically in order to prove that it follows the style guide to some extent. That's how I decided to build Collizer. And Collizer has mostly rules related to the style guide. Although we are calling it style guide, some of these errors are actually can be considered as linting errors, not style errors, and they cannot be automatically refactored. For instance, if you haven't implemented the ngOnInit interface, the onInit interface, and you have ngOnInit method, this is not something which is necessary safe to be automatically fixed by Collizer. So this can be considered more of a linting error.
Why would it not be safe for Collizer to fix that?
Well, it might. Well, it's you have definitely bad naming if you have a method called ngOnInit and it doesn't intend to be invoked as a lifecycle hook or ngDestroy or whatever.
Well, I think you've got bigger problems if you've got stuff that's named that than style.
Yeah, that's correct.
So one of the things I'm wondering is, like, you know, we get some stuff at compile time that identifies, hey, you use this wrong. In the template, you try to access a property on an object wrong or whatever, right? Doesn't exist. But if we could get that in our IDE and editors at the time we're typing that code, it's ideal, right? Now, is that something that, does Angular language services fill that gap? Is that where that comes into play in terms of being able to kind of almost run like a compile-like scenario while we're typing the code?
Yeah, what the Angular CLI does, now what the Angular language service does is to parse our template when we start typing something. For instance, when we start typing something into an interpolation, it is just going to take a look at our component and its properties, find a list of these properties, and right after that, based on what we have typed and the properties and the methods of the component, it is going to give us some suggestions. So yeah, that's what it does. In general, it's almost as simple as it sounds, except that we are right now ignoring a lot of complexities, such as inheritance chain and template references, which can be declared like anywhere in our application, and it creates a bit of a mess. But yeah.
Lots of parts, right? And lots of benefits too, which is pretty cool.
Yeah. Yeah, the template references are the biggest pain, to be honest. Yeah, regarding tooling, because you need to have the metadata for your entire application collected in order to give proper suggestions. Otherwise,
One thing that really gets me about the template references, I always want to make most of them private, and you can't make them private. It's so sad.
yeah, I'm frustrated from tooling point of view because it requires me to parse the entire project. If they were private, I was going to be completely happy as well, actually.
Okay, so what other tooling? Anything else?
Yeah, we have, so on top of similar analysis like what Collizer does, we have awesome tools like Compodoc. So Compodoc is developed by Vincent. And you said you had a show with him, right?
Yeah, we had a show, I think last year, maybe early last year. Yeah, it was really fascinating. Yeah,
it's an amazing tool. So basically, it statically analyzes our application without requiring us to run it or anything. It just collects some data out of it. For instance, finds out the individual components based on the component decorator that we have on top of the classes. It finds out their selectors, like their styles, their templates, analyzes the templates, find out the connection between the individual components based on the, for instance, if we refer template B in the template of component A, if we reference it, we'll be able to find out this relationship between these two components, and CompoDoc after that is going to render our entire application. So that's pretty cool thing that Vincent is doing there.
Yeah, so it's not just the documentation, right? But it's also the analysis of the whole tree and structure of your app and all that stuff.
Yes, after it figures out the dependencies between the individual components, their relations, it can output everything into a JSON format or HTML. So we can use it as documentation. Yeah, this is pretty cool.
One of the things I've found that beneficial for was to identify where things in ng modules, and maybe like be able to like visualize that. Then you can see where you maybe want to re-architect that, right? Make other ng modules smaller, or this sort of thing, or the overlap. It seems to be very handy for that.
Yeah, yeah, that's something that I've been working on as well. It's in a tool that I built on top of the Angular compiler. It's ngRef. I didn't mention one cool thing about the Angular compiler. So it's not only going to find out all the components in our application, but it also partially evaluates some expressions. This means that, so usually the evaluation happens runtime, right? So when we open our application, we are evaluating some expressions. The Angular compiler can try to evaluate expressions at build time. So this is something that Prepack does. That's Prepack is a tool that Facebook released some time back. So what the purpose of Prepack is to just take our JavaScript, evaluate everything to the point where we cannot evaluate it anymore because we need some runtime information, like let's say user input or anything. And from there on, we can just take this and put it through Uglify.js or anything, which is going to make our application run even faster than usually. So the Angular compiler does this as well, but not to such extent. So because imagine that we have a component decorator somewhere, and the selector of the component decorator, it is not defined inline inside of the decorator itself, but instead it is defined in a variable, in a, let's say, constant somewhere outside of the component declaration. In this case, the Angular compiler is going to follow the reference and find out where exactly the selector is defined and figure out what the value of the selector is. So this is something which works already. And yeah, so I didn't mention this thing, which is a very powerful feature of the compiler. And thanks to this, we can build even more advanced tools for static analysis and for visualization of source code. And this is something that I'm taking advantage of in an Electron application that I built some time back, ngRef. It just visualizes the dependency graph of your application.
And so how do you use that? Do you just launch that app and then point it at your binaries or your build output of that, and then it kind of does magic?
Yeah, you open your application, you open ngRef, you select your tsconfig.app.json file from your Angular CLI project, and it finds out the dependencies and the relations between the individual modules and everything.
Interesting. That sounds cool.
It is based on the Angular compiler, so it can do anything that the compiler can. So that's the cool thing about it.
And does it handle large applications, a bunch of files? Is it pretty fast, or how is it basically the same kind of speed as the compiler, or what?
It was super slow actually on Christmas. And what happened was that Igor told me, messaged me on Twitter and told me this app is slow. So yeah, I left Christmas a little bit earlier and fixed it. So now it's much faster. It's running the entire parsing stuff into a background process, because with Electron you have this blocking, which is not very convenient. So it runs everything into a background process, parses your application, and right after that pushes back the structure to the main thread, which renders it. So it works fine. It's as fast as or as slow as the ahead of time compilation, like ngC is.
Interesting. So what you have another tool, ngAst? Is it ngAst?
Yeah. So the Angular compiler it is awesome for what it does. Sometimes it provides very low-level API because that's what the compiler does. So on top of the compiler, I built this ngAst, which just provides you a more convenient interface for working with the compiler if you want to do something like static analysis or visualization of source code. So what ngAst does is you just install the library, npm install ngAst. You take the path to your tsconfig file, you pass it to ngAst, and right after that you can get all the modules, all the directives, all the components, like everything from your application.
I'm just my mind just started to think about cases. Sounds cool though. Sounds very cool. So what do you envision for the use of that?
You can use it for anything. I built a Christmas tree garden out of it.
I mean, it sounds like a pretty good tool to like generate documentation as well. You know, something like CompDoc could use it.
Yeah. So I gave a talk. So I have this talk, Mad Science with the ngAir compiler, when I try to give it, something goes wrong. Last time I tried to give it in Russian, the beauty got on fire. And yeah, 2 weeks ago, I was in Google here in San Francisco, and in the middle of the presentation, my keyboard stopped working, so I had to restart my computer in front of everyone. So it was awkward. But after my talk, one guy came to me and told me, "Well, yeah, the Christmas garden is pretty cool, but I would prefer to use it for something useful." So exactly, he said this about documentation. I think it is quite useful for this. Yes.
Another idea that could be useful for is testing, right? If I could, you know, in like a test harness, I could like read out the inputs and just feed it a bunch of different input data to see if the component would break or something like that.
Yes, that's an awesome idea. So yeah, you can get the type of the input as well. You can do pretty much everything.
Yeah. Also, I wonder if like Storybook, you know, or
that's where I was going with that.
could you run the ngAst to generate those things and then just have an easy way to like code up the scenarios and stuff from that?
Yeah. The only requirement there is that ngAst needs to be decoupled from Node.js. I think it is. So you should be able to use it in the browser eventually. Not sure. Yeah, it should be decoupled.
Very fascinating. I think so. I mean, everybody probably agrees, huh? I mean, this is you open this up, you start digging in, and it just there's all these things to think about, all these potentials, all this value, right? That comes out of all this, which is kind of crazy if you think about the fact that like I sometimes wonder with all this compilation things on the with JavaScript and all this stuff, like, did we just start opening a hole and digging in, and then you get excited about these other elements, you pursue it further, but now are we like over engineering things? Is it too much? I don't know, but it certainly there's this draw about it that as you do one thing, a little thing, you're like, oh, I could do this, I could do that, and I don't know. Yeah,
I think we're going in a good path because this is this is somewhere that a lot of people have been before with a lot of compilers, and they know how powerful this can go. So we're just taking the same path, and probably you're going to have some good results.
Hey, Minko, there's a question in the chat from Ed Pelk, who's my friend, and he's very cool. He wants to know if there's a way to get Codalizer with ngServe, or do you need to manually run nglint for that?
You have, you have the watch mode of tsLint, so you should be able to do that. With watch mode of your files, it should be able to. I'm not sure whether you can plug it exactly in ngServe. I guess this is something that I need to discuss with Mike and Hans. But it's possible.
Well, just tell him Ed wants it. So that should, take it to the top of the list.
Yeah, this should be possible.
All right, Ed, you heard it here.
Cool. All right, well, we're getting to the top of the hour. So anything else that you want to mention, Minko, before we get to picks?
No, I think we did a very in-depth, actually, episode about compilers in general today.
I didn't know that you did Codalizer. I should have known that, but I didn't. I'm gonna have to start being nicer to you.
There's a pretty cool logo for that too, and stickers for that.
Oh yeah, I have
stickers left, Minko?
I have 2 stickers left. Yes.
You could view it as you could start being meaner toward him because your errors are happening all the time now too.
Yeah, I can't be mean to Minko.
All right, cool. Let's get to picks. We'll go through our panelists first. Austin, do you have anything?
No picks for me. One thing I will plug a project that I started working on. I started working on some state management, something that kind of takes a different approach than ngRx, and it's a library called ngXS. ngX and then S for state. So check that out.
We might just have an episode coming up on that. Maybe even next week. We'll see.
Is it next week? I don't remember.
It might be. It might be. You might need to get ready. Cool. All right. Bonnie.
Okay, I'm going to reveal that I'm a huge nerd, but you guys already know that. I'm really excited. I've probably already said this. You guys already know this anyway, but I'm just going to throw it out there. ngConf registration starts in 42 days, 4 hours, 2 minutes, and 46 seconds. Yes. So I'm really excited about that. I'm excited to see all my friends, and I'm excited to meet a lot of new people. And if you do not have tickets for ngConf yet, now is the time. You can get them. And we usually start buying plane tickets like a month in advance. So this is the time. If your boss wouldn't let you go to ngConf, just do it anyway. Trust me. This is something I know something about. It'll be fine. Just go. It'll be super fun.
Just
anyway, so ngConf.
Ask for forgiveness than permission approach.
Yeah. Well, the first time I wanted to go to ngConf, my boss wouldn't send me. And I was really upset about it. And so I just took the week off and went anyway. And it was really, really a good decision. And I have never regretted it for a moment. So if you're kind of on the fence, just do it. Just do it. It'll be fun.
Isn't that where we met, Bonnie?
Yes. I met all of you at ngConf. I started I don't even get me started at the end of the show, but just trust me, it's the most fun you'll ever have anywhere in the universe. Go to ngConf. 42 days, 4 hours, 1 minute, and 43 seconds.
Are you going to have any 80s gear? Because the 80s is the theme.
My daughter's having a hard time understanding that. Like, she starts telling me about 80s fashion, and I was like, I was actually there, right? Like, I was actually in the 80s live while it was happening, which is a strange concept for a teenager.
Yeah, I might have to wear my Locomotion t-shirt and like some tube socks and some neon shorts. I don't know. Or maybe not. That time's gone.
Yeah, for sure.
All right. Any other picks? You good on that? Okay. All right. My pick is a tweet by Corey House about poll_request_template.md files in your repos for your open source projects and stuff. You can set that up, and GitHub will automatically read that for pull requests. So you can use that as a template for guide for people making pull requests to your repo. Thought that was pretty cool. That's my pick. All right, Minko, our guest is last. What do you have any picks?
Yeah, my pick is, Codalizer 4.2 is out, and it has support for Angular version 6 and a few new rules implemented by William Koza. So he introduced rules because it's not a good idea to have very complicated expressions and very complicated templates, right? We don't have to put a lot of logic in our templates. So with Codalizer now we can limit this. We have rule for Boolean expression complexity, so our ngIfs cannot get far too complicated, because we're going to tell you that you have reached your limit. And we have also the cyclomatic complexity, which is something that I'm even more excited about. So we're estimating let's say the branch statement complexity and how many conditions you have and how many ngIfs and how many ngFors. And if you have too many of these, we're going to give you a warning so that you don't make your templates too complicated.
I really like that. I think that's going to be super valuable. I think that's something that we get into. It's easy to get into writing your template code. I think for people to start thinking about maybe other templating systems or server-side rendering stuff that they've done before, like PHP or ASP.NET or something like that, where you just start loading logic in your templates and you could get into these performance and scenarios. And so it'll be nice to have some guidance and kind of like a poking and say, hey, maybe not.
Yeah. Yeah, that's pretty much it. And I also saw an issue some time back about, that's my second pick from the TypeScript type system, that it's already as powerful as a programming language. So yeah, that's something cool and dangerous. That's my second pick.
Awesome. Well, we really appreciate you taking the time coming on, sharing your knowledge and talking about this stuff. Thank you very much for coming on. Appreciate it.
Yeah, thanks for having me. It was a lot of fun.
Yeah, anytime. We're going to have to plan another episode. Have you back. All right, kids, friends, that's it. Another episode in the books, and we will catch you next week. Later.